Okay, now certain things are happening in between 0 and 1. So we have x cube minus x by 2 uh, plus 1/3. So we have, let's pick the interval. So fx is equals to x cube over 3 minus x by 2 plus 1/3. So if we take the derivative, we get x square minus half. So let's find out where this derivative becomes 0 to find the extrema. So this becomes 0 when x is equals to 1 over square root of 2, because we are only interested in the interval 0 to 1, right? So we disregard this particular, the other root of this equation. So we take only x equals to 1 by square root of 2. Now, at 1 by square root of 2, 1 by square root of 2 would be a little here, somewhere here. Let's find out the value. But before that, let's find out whether it's a minima or a maxima. So f double prime x is 2x. Plugging in x equals to 1 by square root of 2 gives you 2 times 1 by square root of 2, which is square root of 2, which is greater than 0. So clearly at x equals to 1 by square root of 2, we have a local minima, because the second derivative is positive, right? So we have a local minima. So it's somewhere, we can even find the value of the local minima. Let's plug it in. So 1 by square root of 2 whole cube over 3 minus 1 by 2 square root of 2 plus 1/3. It's hard to find, but this is the value. What we do know is before 1 by square root of 2, so x minus 1 by square root of 2, x plus 1 by square root of 2. This product, this is the product f prime x. This product is f prime x. So if x is between 0 and 1 by square root of 2, then this quantity is negative and this one is positive. So this f prime x is negative if x is between 0 and, actually I wrote it a little differently, x is between 0 and 1 by square root of 2. If that happens, then the first derivative becomes negative, so it comes down. Something like this happens, and then it goes up, because we can similarly show that if x is between 1 by square root of 2 to 1, then the first derivative is positive. So clearly at x equals to 1 by square root of 2, we have the minimum value. In between it, we have a slope thing like this, and of course we have straight lines otherwise. This is the completion of the problem, and problem asks what is the minimum value of fx. So it is sufficient to say that at x equals to 1 by square root of 2, whatever the value is, and that value we computed earlier. It's not a very neat form. Probably this can be made a little bit more precise. For example, one could write, let's try to make this a little bit more precise maybe. This will be 1 by 6 square root of 2 minus 1 by 2 square root of 2 plus 1/3. So this is 6 square root of 2 is the LCM. So we have 1 minus 3 plus 2 square root of 2. So this is 2 square root of 2 minus 2, 6 by root 2. So we can take root 2 common. So we have 2 minus root 2 by 6 root 2, which happens to be 2 minus square root of 2 by 6. So if you know what is the value of square root of 2, which is 1.414 approximately, then you know that this is 0. Let's take it as 0.58, 0.58 by 6.